Hey guys, this is the notes video for the Polygons and Angles and Polygons note sheet. And so this should have been with your, in that assignment. And so you could print this out and follow along and copy it down, or you can just use notebook paper. I know some of you don't have a printer. And so whatever is easier for you is fine. You do need to be taking notes, okay? So you're either writing it on the note sheet that you printed, or you have copied this down. You're copying on notebook paper. Okay, so I'm probably gonna have to split this up into 2 videos. So make sure you watch both and we'll see how long it is. But I think I'm trying to keep these less than 15 minutes each so that they upload faster. And so if this gets to be close to 15, I'll stop it and finish it on a second video and they'll both be posted there together. Okay, so this is polygons. This is still gonna relate to area. We've talked about the basic or the area of all of the basic shapes. We are going to talk now about 2 more things. One is area of regular polygons. And so what do we do if we have a decagon or an octagon or a hexagon, and it's not one of our kind of basic shapes that we've already done? As long as it's regular, then we can use a special formula, which we will talk about in our next section. But before we do that, you need to know some basic things about polygons that we haven't talked about yet. And so that's what we're going to do here. So this is not area, but it is going to, what we use or learn here today is going to be used next week when we talk about area of regular polygons. Okay. And so first I'm going to try using a pencil because I prefer that, and I'm going to see if it works. If not, I will switch to a pen if I can't see it here in the video. And so what is a polygon? A polygon is a closed figure with segments for sides. So a polygon has to have, this pencil's out of lead, has to have straight sides. There's no curves in a polygon. Okay, so a circle, not a polygon. We sometimes talk about circles when we talk about other polygons because it's a basic shape that we learn about, but it's not actually a polygon because it's not straight. So let's look, or it's not made of straight sides. So let's look at a few examples of things that are polygons and things that are not polygons. And so an example of a polygon would be a triangle, a square, or a rectangle. A polygon can also be an irregular figure. So this is straight. I made a little slanted, but that is still a polygon. All of these are closed in that there's no open sections. And so here's some examples that are not. This, not a polygon. You could even have, like if you had straight sides and just one curve, not a polygon because it has a side or a section that is not curved. These are both closed, and so you can't, that is an example of closed. Here would be an open figure, okay? It's sides, but it never connects. So you could go, you could go into the figure. So that would be not closed. So these are all examples of shapes that are not polygons. Concave and convex, how can you tell the difference? Concave, I think, is easier. I usually, when I'm trying to decide, I look at a figure and I say, is that concave? Yes, great. No, then it's convex. So it's one or the other. Concave, I always remember it as it caves in. So concave, okay, caves in. Okay. So it's going to have a little piece that kind of goes in towards the center. So this one here, this is concave because this part goes in towards the inside of the figure. It caves in to the figure. Whereas this is just sides that all connect. So this is convex. So I usually look at a figure and say, is this concave? Does it cave in? No, then it has to be convex. The official definition has to do with diagonals, and if you traced the sides or tried to connect vertices, if it has to go into the figure, if you connect 2 vertices or you try to draw them in, it goes inside. And so, or I should say, that's if you trace a side and extend it, really, is what they're saying. So like these would be fine. I can trace these 3 sides and it's the outside. Okay, even if you extended them, they don't go into the figure. But this side right here, if you trace it and extend it, it goes into the figure. That's how you know, that's the official definition of being concave. But I usually just decide if it caves in, is how I figure it out. Okay, so you need to be able to decide if a figure is a polygon, if it's concave or convex. This next list, I just want us to know these basic names. So these are the names of polygons based on their sides. These, on this list, you do need to know. So, you know, when I say something like a quadrilateral, you need to know how many sides that has. That's going to be important to figuring out some of these other pieces that we're going to talk about. So two sides, this is not a thing, so this is not a polygon. Okay, a polygon has to have at least 3 sides. So there are no 2-sided polygons. You can't have 2 straight sides that are also closed. You would have a 3rd side that connects them and closes the figure. So 2 sides, not a polygon. Okay, 3 sides is a triangle. 4 sides, we have already talked about this. This is a quadrilateral. 5 sides is called a pentagon. Some of these you probably know pentagon. It's probably not new information. 6 sides is a hexagon. Okay, I'm going to stop for a second. I kind of wrote those fast, so let me give you a minute to catch up. Okay, 7. This is not one we talk about a lot, so it's not one that people know just off the top of their head. Typically, so you may not have heard this before. 7 is heptagon. Hept with a PT, heptagon. 8, you've probably heard, is an octagon. 9 is a nonagon. It is not ninagon with an I. It's nonagon with an O. So you are going to be responsible. Like if I say on a quiz or a test, this is a 9-sided figure, you have to know what that means. You have to be able to spell it. Okay, so make sure that you wrote that down correctly. Number 10 is a decagon. 11 sides is also not super common that you talk about this. We will do a few examples here and there with 7 and 11, but so you may not have heard this. This is hendecagon. And then 12, this one's my favorite. This is dodecagon. Okay, so those are the names that I would expect you to know. Here is a little opportunity for some bonus points. So this will be for those of you who are actually watching the video. You'll catch this. I'm not going to post this anywhere else but this video. So if you're not watching, those of you who don't watch are going to miss out. So if you will look up, okay, the names for 13 through 20 sided polygons. Okay, so 13 through 20 sides, they're kind of weird. I'm gonna be honest with you, they're super weird. I have done this before with students and sometimes I get 2 different answers. So if you may find 2 different options, you just need to send me one. There's one really accepted one, and there's one that I say every once in a while that students will turn in. So if you can find me the names for 13 through 20 sided polygons, okay, and then email me the names and the website you found them from. Okay, please do not just email me the names because I'm not going to know if you really did the research or if you had a friend text them to you and you wrote them down. Okay, and so please, you can send me the link in an email if you just want to find it, do a little Googling or a little research and find it, send me the webpage. That's totally fine. And I'll throw you some bonus points if you do that. So feel free to do that and email that to me. Please do that by, let's say Monday at noon. So you should be watching this. You should be watching this video on Thursday or Friday. So that gives you all weekend. The sooner the better so that you don't have to worry about it. But as long as you get it to me by Monday at noon, I'll throw you some bonus points. Okay? All right, so let's talk about regular or irregular figures. Regular figures have congruent sides and congruent angles. Okay, so regular figures have congruent sides and congruent angles. If they're not regular, they're irregular. So if they don't have congruent sides and congruent angles, then they're not regular. And it would have to be all of them. So if you have an octagon and 7 of the sides are 10 and the other one is 6, then it's not regular. It doesn't matter that most of them are the same. They have to all be the same. Okay, we are going to talk, like I said earlier in the video, in our next section about specifically area of regular figures. So knowing that something's regular is really important. A basic example that we've talked about already is a square, because a square has all right angles and it has congruent sides. So a square is a regular quadrilateral. An equilateral triangle is a regular triangle. We've already talked about how all of these angles are 60 and all the sides are congruent. So a square is a regular quadrilateral. It's the only regular quadrilateral. An equilateral triangle is the only regular triangle. There are regular shapes for every number of sides. And we will see lots of that in the future. Okay, going to the next page. Okay, it says, name the polygon by its number of sides, then classify it as concave or convex, regular or irregular. So this has 4 sides, which makes it a quadrilateral. Okay, all of these sides are not congruent. You can see that visually, but also they're all marked with a different number of symbols or segment little markings. So this is going to be irregular. Okay, and none of it caves in, so it's convex. It appears to be a trapezoid. It really looks like these are parallel. We don't know for sure, but it does appear to be a trapezoid, which would never be regular. This next one, there's all different, well, how many sides? There's 1, I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So this is a nonagon. Okay. They're not all the same. This has 1, some of these have 1, then these are congruent, then these are congruent. So this is irregular. It does have spots that cave in. And you can tell if I trace this side and extend it, it goes into the figure. If I trace this side and extend it, it goes into the figure. There's several sides that do that. So this is concave. These cave in. Okay, this next one right here, this is a triangle. It has 3 sides. They are all congruent. All the angles are congruent as well. So this is regular. And as I said just a few moments ago, this would be equilateral, which we know because all the sides are congruent. And this is convex. None of it caves in. This last one has 4 sides. So it's a quadrilateral. Now, all of the sides are marked congruent, but we don't know anything about the angles. And it actually, I mean, if we don't trust visually typically, but you can see this angle clearly looks smaller than this one. They could draw markings in there and say they're congruent, even if they don't look congruent, but they haven't done that. So since we don't know anything about the angles, we say this is irregular, okay? We don't know for sure, so we're calling it irregular because it does not mark the angles congruent, but it is convex. It does not have any sections that cave in. Okay. All right, we're at 13 or 14 minutes. So I'm going to stop this video here and then I'm going to just pick up with perimeter and keep going. So make sure you tune in and watch the second video.